We're going to begin with the domain. We see that there is a denominator, and denominators can never be 0. So we have x minus 1 is not equal to 0. Therefore, x is not equal to 1. We're just adding 1 to both sides. Removable discontinuities. What you do is look at the numerator and denominator and try to factor them and see if anything divides out. In this case, nothing does. Asymptotes. Asymptotes happen when the denominator approaches 0 and when the value of x is very large. So when the denominator approaches 0, that will be at x equals 1. That will be a vertical asymptote. Doink, doink. And the horizontal asymptote is what happens as x approaches infinity. What you do is you look at the highest degree term in the denominator and the highest degree term in the numerator and take a look at their ratio, and that would be y equals 1 is the horizontal asymptote. The intercepts, we will put 0 in for x, and we will get 0 over negative 1, which is 0 for y, and that's going to be the y-intercept too, because it's the x-intercept too, because it's crossing the x-axis there also. Now let's look at a sketch. Let's sketch in our vertical asymptote at x equals 1. And we have a horizontal asymptote at y equals 1. We know we have an intercept here. We know basically it exists everywhere except for at x equals 1, so we have to draw a function in that area. And we can't get a function down in this area because the function doesn't cross the x-axis at any other points, so therefore it has to look like this. Okay, so now that we have that, the intervals where it's increasing, there are none. This is decreasing over its entire domain. And the last one, the limit as x approaches infinity, is positive 1.